Okay, we need to look at different kinds of energy sources and how we use them in power stations. Now we need to identify different world energy sources. These you know about already: coal, oil, gas, nuclear, solar, hydroelectric, blah blah blah. You know all these already, but we need to classify them. What do we do with all these energy sources? What do we do with all these energy sources? We basically turn them all into electricity. This is the most useful thing that we have. It's such a convenient form of energy that we can run pretty much most of our daily devices from electricity. Okay, so electricity is one of the most versatile forms of energy because we can use it to basically run anything that we have in our houses and in industry. Now, these are called primary sources, and these are called secondary sources, or electricity is a secondary source of energy. A primary source is basically one that occurs naturally. Fossil fuels, biofuels, wind, waves, solar energy, and nuclear fuels as well. Now, you might say that nuclear is not a natural resource. Well, it is. The nuclear fuel, the uranium, is basically dug from the ground. The process that we use it for is not particularly natural. We do make it fission and so on, which it doesn't do by its own, by itself. But nevertheless, the source of energy is natural. But then we basically turn all these into electricity. This is one that is a secondary source, is one that is made using primary sources. For example, electricity is a secondary energy resource. It can be generated by a number of different primary sources. There are other secondary sources, but this is the main one. We need to look at power stations. The power station has basically these energy forms. You have a chemical energy that goes in. Chemical energy gets converted to heat energy. Heat energy gets kinetic. Kinetic energy basically turns the turbine and we get electrical energy out. And this basically gives a diagram to show how efficient the different parts are. So a typical thermal energy power station is only 35% efficient. So we need to outline the principal mechanisms involved in the production of electrical power. Here we have a coal power station. First of all, you must put in chemical energy, first of all, fossil fuels or whatever, and that produces thermal energy, heat energy in the boiler. The chemical energy is turned into heat energy. The next step is that this steam, this kinetic energy, thermal energy, is turned into kinetic energy to make the turbine spin round. Then after the turbine spins round, it's connected to the generator. And from the generator, we're able to produce this secondary form of energy, which is electricity. And that's basically how it works. You can talk about steam being removed and go to the cooling towers. This has to happen if we're going to be able to produce electrical energy. Some energy, some thermal energy, has to be thrown away. We have to cool the steam, and there's nothing to do to avoid that. It's in the law of physics. The faster we want the power station to work, the more thermal energy we have to throw away to get it to work quickly. Sad but true. Now I'm going to classify all these processes in terms of the energy that they're going to produce. We want the electrical energy, so this is what we have out. So we're going to do this thing backwards now. We end up with electrical energy. So where does this electrical energy come from? It comes from the generator, which is driven by the turbine. The turbine is basically kinetic energy. So this is the turbine here, which is driving the kinetic energy. Actually, this is the generator. Where do we get the kinetic energy from? So we look at the kinetic energy. This comes from the turbine there, which is spinning around. And where does this kinetic energy from? Well, it can come directly from hydroelectric power. It can come from wave power, it can come from wind. These are all forms of kinetic energy which are being turned into the kinetic energy of the turbine. On the other hand, the turbine can also be driven by high pressure steam from a boiler. These are basically alternative forms of energy. These are renewable energy. This is the typical way that traditionally we produce electrical energy, is by using a thermal power station. You get thermal energy or heat to produce this kinetic energy, and that's basically from producing steam. Where does that heat come from? It comes from three sources. One is either nuclear energy, this is producing the heat to produce the steam, blah blah blah, or solar energy. This can, in a solar furnace, this can produce the heat which causes the steam, blah blah blah, or fossil fuels. This is the traditionally how we produce this heat. So we have this chemical energy, goes into fossil fuel, gets turned into heat energy, into kinetic energy, into electrical energy. And this is the boiler. This is where this energy conversion first takes place. So in a boiler or reactor, fuel is burnt to heat the water. This boils and generates the steam. So basically chemical energy turns into thermal energy. This top section there is basically what happens in a thermal power station. Now let's look at a little bit more about thermal power stations. They're characterized by a boiler of some kind. There it is, boiler, a turbine and a generator. That's what we need to know. Little details in addition to this are transformers, as a detail we look at in another topic, and of course a cooling tower, which we don't need to look at so much. So a thermal power station uses heat to generate electricity. So it can produce the heat from either nuclear fuel or traditional fossil fuel, or even a solar furnace. These heat engines are always inefficient, and we lose probably 60-70% of the energy as heat to produce this electrical energy. So what part does each do? We need to look at the conversion, the energy conversion. The boiler basically turns chemical energy into heat energy. The turbine is where this heat energy from the steam is turned into kinetic energy. Then the last one is the generator, where this kinetic energy is turned into electrical energy. You need to know the energy conversion that happens with each stage. The cooling tower, who cares about that?